This problem is a hydroboration reaction. Hydroboration is addition of boron to alkene. In hydroboration, H and BH2 is added to the double bond of the alkene. Uh, in hydroboration reactions, you have to consider two things. The first one is a stereochemistry. Hydroboration is always in addition. That means hydrogen and and BH2 are added to the same side of the double bond. The second thing is regioselectivity of the reaction. Uh, the boron atom is bonded to the less substituted carbon atom of the double bond. Less substituted carbon atom means the carbon with more hydrogens. So we can understand this with the mechanism, and let's see the transition state of the reaction. In the first step, uh, the 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 bond between one of the hydrogen and boron is breaks, and that hydrogen is make a bond with carbon. In the same time, the pi electrons are attracted to the boron atom. So this is a concerted reaction. And let's see the transition state. In the, tra- the boron is an electron deficient compound because the boron atom has a 6 electron and it's not an octet. Therefore, it acts as a strong electrophile. In the transition state, the pi electrons are attracted to the boron atom. Therefore, it has a partial negative charge, and the the carbon atom of the other end of the double bond has partial positive charge. And the presence of alkyl groups can stabilize this partial positive charge. Therefore, all the time the boron is attached to the less substituted carbon atom. Uh, then this is the product. So, uh, sorry, this is the product. So here BH2 here and hydrogen. So both hydrogen and BH2 is added to the same side, and boron is boron atom is attached to the less substituted carbon atom. Let's do the problem now. The part A. So here the one side it has two methyl groups, and other side it has two hydrogens. So let's draw the product. What happen when we adding BH3? So always remember the boron is attached to the less substituted carbon atom. That means it's at this side. Or less substituted carbon atom means uh, carbon with more hydrogen atoms. Another factor why it's attached to the less substituted carbon atom is it's a less steric hindrance. So this side it has more alkyl group, therefore uh, it has a steric hindrance, but this side no alkyl group, therefore boron atom can easily attach to this side. It's another factor, but the main factor is in the transition state. As I explained, there is a partial positive charge on the other end of the carbon, so that can be stabilized by the alkyl groups. Therefore, the product of this reaction is here it has a 2CH3 groups, and it has two hydrogens, and boron is added to the same side, and boron is added to the less substituted carbon atom. This, let's do the part B. Here it has a part it has a two hydrogen atoms here, and this has only one hydrogen. Therefore this side is the less substituted side, or the carbon with more hydrogens, therefore BH2 is added to this side. Okay, let's draw the product. So product is uh, BH2 is added to this side, and here it has hydrogen. Let's see the part C. The part C, one side of the double bond is two hydrogen atoms, and this side has a cyclic ring. Therefore, this side has the less. This carbon is the least substituted carbon, and it has a less steric hindrance. Therefore, BH2 is added to this side. Let's draw the product. So this side it has hydrogen. Therefore, BH2 is added to this side, and hydrogen is to this side.